Hi out there. We have someone with their mic on. If you could mute your mic, please, that would be fabulous. And we'll be starting in about 1 minute. Thanks for your patience.
Welcome to A Decade Number and Taking Jumps of 10 Forward and Backward. We are so glad you could join us on this new presentation endeavor. Today we are your hosts, Mariah, Holly, and Cheryl, and together for the next 30 minutes we will be navigating you through this virtual learning experience. If at any time throughout this presentation you would like to ask a question, please enter it in the chat box. We will do our best to answer your questions and troubleshoot as quickly as we can. We will mute your microphones to avoid any reverberating sound feedback. Are you ready? We hope so, because here we go. The Continual helps students develop a variety of strategies to use as they work with numbers to solve problems involving addition and subtraction. Getting to a decade number and taking jumps of 10 forward or backward is a strategy that incorporates many of the other strategies in the working with numbers phase. Our goals for this session are to clarify decade numbers, show flexible ways to decompose numbers to make jumps of 10, as well as share some activities and games to support this learning in your classroom.
You've seen these 10 frames in many different forms. As you know, it all starts with dots and subitizing. We recognize a quantity and determine the amount in an organized structure of 5 and 10. How many more dots do you need to fill the 10 frame or make 10? Or in other words, what's the other part of 10? These are essential building blocks for getting to a decade number to make jumps of 10 forward and backwards. It will take many different exposures of the same concept, sometimes over the course of several years, for these bonds of 10 to be internalized and recalled automatically. These are the building blocks of our mental math skills, and the time spent developing 10 is so important. In the activity illustrated, students combine 2 Cuisenaire rods to equal the length of the orange rod. To phrase it differently, what 2 rods combined will equal 10? What is the matching number sentence that goes with each rod present representation? Before we start numbers greater than 10, you want to make sure that students understand their teen numbers, those numbers that are 10 and more. I like to say teen and more. Can they represent these numbers using 10 frames to see that the most efficient way to make 13 in 2 parts is by using one completely filled 10 frame and a frame filled with 3 dots. 10 plus 3 is 13. A number path and a number line. What's the difference, you ask? A number path is a count model, and the numbers are represented by a rectangle, and each rectangle can be counted. Whereas a number line is a length model, and each number is represented by a tick and its length from 0, from one tick to the next. Children often start counting all the ticks, and their count is off by 1. The number path model helps young children count the easy to recognize rectangular units rather than the space between the ticks. It's a subtle difference, but the rectangular units in the number path supports the developmental understanding of our younger learners.
Counting by tens from any number. You have probably noticed that when you ask students to count by tens, they quickly start the rhythmical chant of 10, 20, 30, 40, etc. If you ask them to start counting by tens starting at 40, you will probably see them bobbing their head 3 times and simultaneously mouthing the numbers 10, 20, 30, and then start counting out loud for the rest of it, 40, 50, 60, etc. Ask them to count by 10 starting at 2, and they will tell you that it's impossible. They don't believe that it can be done. That is when we give students a color of counter, for example, red, and assign them a number on a number path. In the above example, we have assigned this child the number 7. They place a chip on the 7 and then count on 10 spaces and place the next chip on 17. They place a chip on the number that is 10 more than 7. While students do this, notice if they jump to 17 or if they count by ones to 10 to land on 17. Students continue to place the next chip, counting on by tens, until they have run off the path. You can have up to 4 students on the same number path and assign them a different number and color of chip and have them place their colored chip every 10th square. Now it's time for each child to walk forward beside the path, counting out loud, exaggerating the steps and the strides of 10. In this case, red would walk forward, stepping by each of their colored chips, saying 7, 17, 27, and so on. He would wait at the end until every other person has counted on by tens forward from their starting number. Then it is time to take jumps of 10 backwards. The red student steps and says 97, 87, 77, and so on. Regular chanting and practicing of counting on by tens from any number will help students internalize the tens pattern.
We need to strengthen the counting of tens pattern by connecting it to other representations. Using another 10 chips or counters, show your string of numbers on a hundreds chart as well. What do you notice? Students need to understand that a hundreds chart is basically a number line that has been chopped up into rows of 10 and stacked together. When you count by tens, the digit in the tens column goes up by 1 because we are adding another row of 10. The digit in the ones column remains the same. Connecting all of these visuals and the movement of walking the number path forward and backward may strengthen the connections to the brain of counting by tens. Students need to have numbers visible to them at all times and in close proximity. As you transition from a number path to a number line, there are many creative versions of number lines from which to choose. You probably have seen many of these in your schools. Models where the tens and even fives are highlighted or marked strengthen getting to a decade number and making jumps of 10. We're going to spend some time now sharing student examples and activities using number lines. This number line is many great
using familiar facts.
The tens are clear. We have someone that's muted their needs to mute their microphone. We're good. Awesome. Thank you for that. The tens are clearly marked and the fives are less pronounced, but still darkened to be noticed. This helps reinforce the 5 and 10 benchmark numbers. Some quick formative assessment to have students identify 2 given numbers on a number line will give you a good indication if they are ready to move on. Have them identify another pairs of numbers that are 10 apart. For example, some prompts that you might use are find numbers that are 10 apart and end in a 5, or find numbers that are 10 apart and end in a 7. Find numbers that end in a 0 and are 20 apart for the next challenge. Seeing the numbers spatially will help them get to a friendly decade numbers and make jumps of 10.
Connect jumps of 10 from one representation, such as the hundreds chart, to jumps of 10 on a number line. Notice if students are counting on by ones or making a full jump of 10. In the top example, students started at 9 on their hundreds chart and counted by tens and showed these same jumps of 10 on the number line. In the bottom example, a student used a hundreds chart and a number line to show that 55 plus 10 equals 65. When students are comfortable with jumps of 10, we can move on to other multiples of 10, such as 20, which is 2 jumps of 10. The student sample pictured in this slide shows adding 20. For 5 plus 20, a blue chip was placed on the number 5 on the hundreds chart, and when adding on 20, it shows 25 covered with a green chip. This same question modeled on the number line starts at 5 and with 2 jumps of 10 arrives at 25. Other questions modeled on this chart and number line reveal 32 plus 20 equals 52, 58 plus 20 equals 78, and 79 plus 20 equals 99.
When you use a meter stick or a tape measure as your number line, you can use a base 10 rod or an orange Cuisenaire rod as your counting unit of 10. By design, each of these is 10 centimeters long. This allows counting on by tens from any number with a concrete manipulative. Students can put a mark under their starting number and a mark under each number they advance to when counting by jumps of 10. You can give them a question such as, you start at 35 and you add 5 jumps of 10. Where do you land? Make a number sentence to show your work. Show your jumps on a whiteboard using an open number line. An open number line is a line on which only significant numbers are recorded. In the above example, to show 35 plus 50, the student started at 35 and made 5 jumps of 10 to get a total of 85. An added bonus of using the base 10 rod to make jumps of 10 will help their linear measurement. Having many opportunities to hold and work with a decimeter rod in their hands will strengthen their understanding of this particular unit of measure. When students are presented with a problem of 17 plus 12, they have many decisions to make and can solve it in many ways. In this particular example, a child started at 17 and they decomposed the 12 into its place value parts of 10 and 2. They kept one number whole, the 17, and then they added on a jump of 10 to get to 27, and then added the 2 single jumps of 1 to get to 29.
In this example of 27 plus 22, the student kept the 27 whole and decomposed the second number into its place value parts of 20 and 2, and added on 1 jump of 20 on their number line and 2 jumps of 1 to get to a sum of 49. Some students will show the adding on of 20 as 2 jumps of 10. Both are totally fine. Another student may decide to add 2 to the 27 first to make 29 and then add 20. What matters is that they are working with the numbers in friendly parts. Regardless of the tool that they are using, it is important that students connect a variety of representations. In the example of 35 plus 50, the child selects their start number of 35 and decomposes the second number in easy to add on parts. They underline their numbers on the tape measure and then create their model on an open number line on their whiteboard. Taking a look at the second example, students may need additional support and scaffolding. To support the learner, you can give them the starting number and the multiple of 10 to add. They can identify the number of jumps of 10 in a given multiple that they need to add. The number line is a tool that helps children develop greater flexibility and mental arithmetic as they actively construct mathematical meaning, number sense, and develop their understanding of number relationships.
Money. This is another kind of representation. Once students enter grade 2, they will be asked to make change from $1. One strategy is to find the difference between the money amounts by counting up to the next dollar. Counting up by tens or dimes on a number line continues to strengthen their number sense of decade numbers. For example, in the problem, you bought something for 15 cents. How much change would you get from $1? Count up to find the difference. Another money expectation for students is to make an equivalent amount of money using more or less coins. Nickels create opportunities for jumps of 5. Although not as efficient as using dimes or tens, getting to a friendly number of 5 is also helpful when adding on. The number line is an easy model to understand and has great advantages in helping students understand the relative magnitude and position of numbers, as well as help to visualize operations. Showing computational steps as jumps drawn by the arrows on a number line allows students to visualize the number relationships and actions inherent in the strategies. You may remember the EQAO question where the students were asked to compare how much taller one person was than the other. In the above solution, students added on using friendly jumps of 10 and more to determine the height difference between two people. And what about this problem? Talk to your elbow partner about how you would use a number line to solve this problem. We actually mean talk to your elbow partner. We're going to give you about 1 minute to give this problem a try. sketch it out on a piece of paper, and type one of your group solution in the chat pod. So again, how would you use this number line? We're going to pause for a minute while you share with your elbow partner. Thanks for giving that a try. We noticed, or some of the things that you might have noticed when you were talking with each other, is that you had different starting points and you moved in different directions.
We're starting to get some answers now. So start at 85, then take jumps to get to 67, start at 67, jump of 10 to 77, jump 10 to 87, jump back 2, start at 67 and jump by groups of 10.
Oh, awesome.
Start at 67, and they use the same strategy, I think, as Indian Creek. Starting to get lots. I can't even keep up.
Wow, this is amazing. Thank you so much for all that feedback, everyone.
Mm-hmm.
And we're going to look at those comments after as well. So if you notice that there were, if you saw subtraction as removal, you may have started at 85 and made a jump back of 5 to get 80, and then 6 jumps of 10 to get 20, and then a jump of 2 to get 18. Now, if you saw subtraction as the difference between the two numbers of 85 and 87 and counted backwards, you may have started at 85, made a jump back of 5 to 80, and then a jump of 10 back to 70, and then a jump of back of 3 to 67, determining that difference between those two numbers is 18. Now, if you saw subtraction as a difference between two numbers, again, of 85 and 67, you may have decided to add up. I love adding up instead of subtracting. What about you, Holly?
So much easier.
Oh, no kidding, eh? And so maybe you just said, I'm going to start at 67 and go to 85, but I'll do it with a jump of 3 to 70, then a jump of 10 to 80, and then a jump of 5 to 85. The difference? 18. Either way, you've got the same answer. Lots of opportunities and options to do that. A number line is a powerful mathematical tool, and it promotes an understanding that can be used in numerous mathematical contexts and with different types of numbers. When students can make sense of the problem, visualize the numbers in front of them, and add on or remove in groups of 10, the problems don't seem so daunting. What would be the alternative? A traditional algorithm where they put 67 under 85 and try to subtract and regroup? What happens? They get a difference of 22 because they don't regroup, and they say that 5 minus 7 is 2, and 8 minus 6 is 2, so the answer is 22. What method will better help them understand the quantities and make sense of numbers?
In this next part of the session, we will share some games to reinforce the strategy of getting to a decade number and taking jumps of 10 forward or backwards. We have created a Google Drive folder that will be shared with you at the end of the presentation that will have the games that we will be talking about today. To play the game Going to 100, players need a deck of cards, ace to 9 only, and the value of the ace is 1, and a number line, commercially or student created. Players place a deck of cards between them. Player 1 pulls the first card from the deck and marks this number on their number line. Player 1 then flips a second card and adds this number to the first one by showing on the number line how the number was decomposed to get the next decade number, and then adds on the rest. In the example above, 7 was the starting card, and 8, the second card, was decomposed into 3 and 5, adding the 3 first to get to the decade number of 10, and then the remaining 5 was added on for a total of 15. Next, it's player 2's turn, following the same steps. Players continue to take turns. Each consecutive turn after, players continue to pull 1 card and add it to the running total. The player that arrives at 100 or more first wins the game. There are lots of modifications you can make to this game. If your students need 10 frames to help with decomposing the numbers to make 10, you could play this game using 10-frame cards. You can extend this game in order for students to practice taking jumps backwards, calling it moving back from 100. Have students complete the same activity, however, with subtracting from 100 on their number line. When students start this game, they will only have to pull 1 card and subtract it from 100. Every turn thereafter, they will continue subtracting from their running total, always showing the jump on their number line.
Wow, I think kids are really going to like that game, especially when they play with cards. Super. The second game is an extension to the previous game of going to 100, just adding a little bit more challenge now. Once students are confident with decomposing numbers to get to 10, students are ready to start splitting numbers between 11 and 19, adding the 10 and what is left over. This game is called 10 and More. The teacher can choose a target number for the groups depending on the time you have. So maybe your target number could be a 100, 400, 300, etc. Player 1 flips their first card and adds 10 to it. For example, if they flip a 7, they start with 17. And then they turn over a second card and add 10 to it, and then they add it to the first number. So for example,
Support student numbers.
if you start with a 7, then an 8, you will really be adding 17 plus 18. Students will continue to show their running total on an open or ready-made number line. The first player who arrives at their target number wins. Again, you can extend this game in order for students to practice taking jumps backward, calling it moving back from, and then whatever your target number is. Have students complete the same activity, but first try it with subtracting from 100 on the number line before moving on to a larger whole. When students start this game, they will pull 1 card and add 10 to it, and then subtract it from 100. So if they pull a 7, it's really 17, which is removed from 100. Every turn thereafter, they will continue subtracting their number from their running total, always showing their jumps on a number line.
And when students are confident with adding 10 and more, you could progress to 2-digit add-ins. For the game Race to 1000, the goal is to be the first player to arrive at 1000. This target number can be changed to meet the needs of the students, or depending on how much time you have. Players place a deck of cards between them. Player 1 pulls 2 cards. Card 1 is the 10s, card 2 is the 1s for the first double-digit number. The player represents this number on an open number line. In the game pictured above, the first number is 89. Player 1 then pulls 2 more cards. Again, card number 1 is the 10s, card number 2 is the 1s for the new double-digit number. The second number for the first turn above is 75. Player 1 shows how she will add the second add-in to the first add-in, for example, 89 plus 75, by representing it on a number line. Students are encouraged to show how they will get to a decade number first. In the example above, 89 plus 75, the student added 1 to get to a decade number of 90, then made 7 jumps of 10 to make 70, and finally added on the remaining 4 to make 75 for a sum of 164. Player 2 then takes his or her turn, repeating the same steps. Now it's player 1's turn again. This time they only pull 2 cards. The first one represents the 10s and the second one represents the 1s. She adds this to the previous total, showing the jumps on the number line. Players continue taking turns until one player arrives at 1000 or whatever target number was identified before the game began. Not pictured, but just as powerful, is the same game in reverse. You can subtract single digits by removing in friendly pieces to get to a decade number and remove in groups of 10s or other multiples of 10s as students are comfortable.
This game, 101 and Out, can be found on page 181 to 182 of the Alex Lawson book, What to Look for in Early Numeracy. The strategy students will use in this game is to take jumps of 10 forward or backward to reach a target number. The goal in this game is to get as close to a target number as possible without going over 100. So player one, in this game, we need one die, 101 game board per player, a number line of your choice, and students create their own number line as pictured above. Player one rolls a die. Suppose player one rolls a 3, like in the top picture. Player one can choose to have the 3 represent 3 tens or 3 ones. If player one chooses the 3 tens option, she records 3 in the tens column of the game board, 30 in the running total column, and records the jumps on a number line. The next player takes a turn. On each turn, the value of the number of tens and ones is recorded in that row of the game board and is added to their running total from the previous turn as indicated on the number lines above. For example, suppose player one rolls a 4 on her second turn and chooses the 4 tens option. She would record 4 in the tens column of the game board and 70 in the running total column. 40 added to the previous running total of 30 gives 70, and make a jump of 40 on the number line. Play continues until all players have had 6 turns. The winner is the player with the sum that is closest to 100 without going over. So there's lots of strategy involved, especially as you approach a higher running total.
We want to strengthen our counting back by groups of 10 as well, so we've modified this game to work on subtraction. We are now starting at 100 and removing the tens and the ones. On the recording sheet, we changed the running total subheading to remaining since we are jumping backwards. Now the goal is to be the closest to 0 without going under. The result of this game was very close as player 1 was 12 away from 0, but player 2 was even closer as they were only 9 away from 0. Showing this removal on an open number line models the actions each player took in removing friendly chunks. When numbers were decomposed to get to a decade number, such as in the 6th turn in the bottom example, when player 2 rolled 5 and were removing from 14, they removed 4 to get to the decade number 10, and then removed 1 to get to 9, and a circle connected the 2 numbers that made up that roll of 5.
You may have seen the Number Talks book by Sherry Parrish, or even have your own copy. In this book, the mental math strategies which connects getting to a decade number and taking jumps of 10 forward and backward strategy on the continuum are making tens, landmark or friendly numbers, removing or counting back. Look at the Number Talks book to find a variety of number talks for each of these strategies at varying levels of difficulty.
When students use the strategy of getting to a decade number and taking jumps of 10 forward or backward on a regular basis, they are working with the numbers and are well on their way to the next phase of developing proficiency.
Well, that's it. Thanks for joining us this morning. We hope that we have given you some additional ideas to help support your students to use decade numbers and jumps of 10 to their problem solving and mental math. Remember to share your experiences with getting to a decade number with us on Instagram and Twitter at LKLMPro, #EngageLK. If you scan the QR code that's pictured, it will bring you to a folder with the resources from today. Just go into the folder titled Getting to a Decade Number. If you have any questions or comments, please feel free to email us and enter your comments in the chat window. Enjoy the rest of your day and have a fabulous weekend. The forecast is supposed to be fantastic. So saying goodbye to you now from Cyberland is
Yes, Holly and Mariah.
and Cheryl. And thank you for enduring and persevering with us throughout this new endeavor for us. We hope you enjoyed it. Thank you so much.
Thanks.
Bye. Woohoo!